Hello, I am Molly Vick, and this is my Physics 2 Lab 3 black hole. So content today that we will go over, I'll first go over the principles I used, my computational model, calculations, and then assumptions and conclusions. So the goal of the lab and the problem we are trying to solve, first we have to determine the mass of the black hole using data from its interactions with the star. I used GlowScript and my Georgia Tech email address to create a computational model to direct the star's trajectory around the black hole. Then we're going to calculate the gravitational net force of the black hole on the star. Lastly, we will apply Newton's first and third laws. These are the principles used for the lab. We will use Newton's second law in the lab. We took the derivative of momentum with respect to time and split it up with its parallel and perpendicular components. We will use this to calculate the mass. On the right, we have Newton's law of universal gravitation, which helps us solve for the net force. The only force on the star is the gravitational pull of the black hole. If we set the two equations equal to each other, we can solve for the unknown, the black hole's mass. Here are my initial conditions in GlowScript. So G is the gravitational constant, this is the mass of the star, and then the time is how many seconds are in a day, so that's delta T. And here's the email address that I used. So important formulas. In our first section, we applied our basic definition of momentum and the change in momentum, as you can see. And then below this, we applied Newton's second law and set dp dt. Next, we break up F net into its parallel component that will be used later to find the perpendicular component. The next code shows how we use our data with arrows. We set the arrow scale, and then we multiplied all of these by the arrow scale to scale them with the model. Now we will run the program. So here is our computational model of the black hole and the star. As you can see, when the star gets closer to the black hole, the arrows get larger and longer, which indicates Newton's universal law of gravitation, as it is an inverse relation. So here are our calculations and data. The black hole's mass was not consistent and fluctuated. This could be attributed to an imperfect model. I derived the minimum, average, and maximum by using Excel. Here's my code that applies Newton's universal law of gravitation to find the black hole's mass. And here is our other data that we derived through the model as output. So part 2 of the lab, the goal is to fly around the black hole in a spaceship without crashing on the planet or the black hole. To do this, I determined what initial velocity my ship must have when it leaves the surface of the planet. Here's my code. So I got this mass of the black hole from my previous model, and here are the constants, and I set my Tmax to 3 hours, as you can see here. Next, I will set the initial conditions for the code for the speed and the velocity. I set the initial velocity of the spaceship based on my model, and here it is. Then I changed the code of the formulas to calculate the net force of the spaceship and the net force of the planet. In order to make it move, I applied Newton's second law. Here's the formula that I used right here. So now we will look at the output. Here's my model based on the code, and it is sped up just to make it faster. The spaceship does not hit the black hole, but it does get close to it. And so this is my output, and at the bottom you can see how many minutes. And so what does this mean? Momentum and force represent two different principles. Momentum continues the motion of an object, and force causes the motion. The parallel and perpendicular components of net force are what causes motion in a certain direction. The net force components can be thought of as the cause of the star's motion, and therefore a change in the star's momentum. So what if? To have it start in an orbit around the black hole, we calculated with the trial and error. I reduced the initial speed by 1 exponential and can see that the ship in its magenta enters the orbit and the planet is the blue. I feel like this drawing would be what it would look like. Thank you for listening.